Okay. So what is database? What is database? The database is a software, right? Okay. So it is a software. Okay. Then
Would
what's the need of developing a different software? To manage data, right? Now, when you say manage data, what all things are included in managing? One is you need to store the data, right? Make sure data is available always, right? And also reading and editing data should be easy, right? Now, see, you can store data in Word document also, Notepad also, but it's not easy to manage. Okay, it's not easy to store the data. I mean, it's easy to store data, but when you have GBs and TBs of data, then it becomes difficult, right? So we need different software. Now, the different software, if you look at the history of database, there will be different types of database we come across: network database, hierarchical database, etc. We will not going to go into history. For us, what is important to know is the most of the database, almost like 80 to 90% of the database that are currently used, they use a relational database management system. Okay, they're called RDBMS. Okay, this is the database which currently we use, and all the popular databases you can think of, all the popular databases that you can think of, like SQL Server, Oracle, okay, MySQL, SQLite, Postgres, all these are example of RDBMS. Okay, so what is R here? What R says is, that physically you need to store data in a table format. Okay, uh, so when you say table, it stores data in column and row format. Okay, it stores data in column and row format, and related data is stored in a, we call it as table, and table has row and column format, right? And you'll have multiple tables. All these tables would be linked to each other. Okay, so what RDBMS says is data to be stored in table format. Okay, table should have rows and columns. Okay, COLUMNs. Rows are called records in database language. Okay, and what a column called that? Tuple. Okay, you can call them a column itself or tuple. Rows are called record. Each row is called a record. Okay, so when you say give me a record, what does that mean? Okay, it means that you want one row, right?
never.
And you can have records, like multiple row or records. Okay, and it says all the tables have to be directly or indirectly connected. All the tables have to be directly or indirectly connected. Okay, or linked or related. That's what it's called, relational. Okay. Now, if you talk about the structure, the way, or the different type of work that are done on database, okay, any database for matter, work we do. So generally we do admin kind of work. Okay. Now this is about like installing, okay, taking backup, security, etc. Right? So making sure that fault tolerance, like, if one database goes down, okay, the system should not stop, right? System should not stop. It should, move to different database, right? So that's what we call as admin. And uh, each of the software that I mentioned, Oracle, SQL, they're all different. Okay, the physical form. So admin, they more work with physical form of the database. Okay, so the physical form of database is different for Oracle and SQL Server. So you'll have, the role they call it as DBAs, database administrator, and you'll have Oracle DBAs, SQL Server DBAs, because the way things are in Oracle is different than SQL Server. The next type of role, we call them as database architects. Okay, they design the database. Now, the design aspect, okay, so physical aspect of database is totally different. Now, when you look at the files and how they are installed, and everything is different. But the logical aspect of database, okay, is same. Okay, so when you say RDBMS, there's a body called as ANSI. ANSI dictates how the database should look like. Okay, ANSI dictates how database should look like. Okay, so now this ANSI, they have rules. Okay, and all these RDBMS, they have to follow the rules. Okay, so the logical aspect of database are same. Are same. Logical aspect. Physically they are different. That's what administration. Logically it's same. Okay, the way the 99% of the command that we will learn, okay, are same across the database. So there's a body, third party, ANSI body, government body, that dictates, they tells what our DMS system should do. Okay, so that's why you see the SQL language is the language of the database. Okay, so SQL, we write SQL, but we call it as SQL. Okay, is the language of database. So we're going to learn another language now. We're going to learn another language, which is SQL language. It is the language of the database. Okay, now so I was saying about the design, right? Now the way you design, okay, is done by these design architects. So they architects, they decide how many tables should we create, okay, what should be the columns of the table, and we will also learn little bit of design aspect. Okay, and then finally you have database users. So we will be database users. Okay, so we will not be changing the the structure of the database, but we will just read, write. Okay, we call it as CRUD, right? So they perform. Okay, we say create new data, read existing data, update existing data, or delete the existing data. These are the operations we perform. Okay, so we will learn how to perform this. Okay, so uh, okay, all these are done using SQL language. Architect, so we'll learn a little bit of this also, and we will learn this also. Now, coming to different types of database, even in RDBMS, based on usage, we have two types of database. One is called OLTP, OLTP, OLTP. Okay, online transactional processing, or transaction processing, correct. And then you have OLAP. Okay, online analytical processing. Okay. So, okay, this is done on live data, mostly editing. Okay. And uh, uh, okay, yes. So here, most of the concept, okay, most of the concept, basic, we have this, right, how the database should be. Okay, basic structure or principle, okay, holds true. So when you say that it should be like this, it should be like that, database should be like, we'll talk about those things later. But just want to tell you, like, when you say database should look like this, database should have this, database should act like this. So all those are true on online transaction processing only. OLAP is totally different. Okay, so this is done on past data. Okay, so your analytics, okay, data science, works on this. Not only this, like warehousing, data warehousing, and data mining. Okay, they all use this. Guessing something? Historical data, past data. That's what I say. Okay. Okay. So, we'll talk about it later. Okay. So, so see, when you talk about Amazon, right? Amazon.com. Now, Amazon.com, when you log in, okay, first step is login, right? So when we log in, Amazon has to validate our username, password, right? So when they validate username, password, so our information is all live there, right? We can go and check our history. We can see what we bought. Okay, we can see what is the status. Okay, we can see what is the status of our product, where the product has reached, etc. Right? South Africa. Okay, so I was saying that when you log into Amazon.com, right, you have to not we Amazon has to maintain the latest record, right? I can see what I ordered today or what I ordered 1 year back, right? So for that, your database have to be online, right? But here, if you see, very rarely we go and check what we bought. Mostly, we are interested in buying new things, right? If your product has not come for long, then you want to go and see where it is. So most of the usage of such database is mainly to enter data. Okay, and there are some challenges associated with that. Okay, because um, if you talk about, okay, so let's say you have a notebook. Okay, so imagine database like a notebook. Okay, and you're writing some text in the notebook. Now you wrote something, you keep editing it. Again, what happens after some time? You will not be able to read what you have written, right? So what happens if we keep editing same thing? So data, it becomes slow. The database becomes, performance becomes slow. So that's why you have something called database maintenance. Sometimes you'll hear that, right? Our system is down for maintenance, right? So what they do is they go and they clean all those things. They recreate indexes, and we'll talk about indexes later. But they make sure that database is now again smooth. So that's why again you'll see that database performance becomes faster. So editing will make database slow. Okay, reading doesn't make sense, right? Like if you have a printed book, reading is like printed book, right? When you printed book, you don't write much on this. right? So it will remain fresh, or the accessibility or reading is almost same when you have the database, right? So OLAP, in the other hand, is mostly reading. So if and this is not done by us, the team will take up, like data warehousing team, data science team, machine learning team, the data analytics team. Let's say they want to perform or they want to analyze data of what customer did for last 3 months. Then they'll say, okay, give me the last 3 month data. They don't want the latest data. They want past data, historical data, right? They want, let's say they want to analyze till December, right? So obviously they don't need January data. They will take Jan to December data last year. Okay, and the data is taken off and given a copy, right? Will be created a copy and given to the team to perform. So that data is not latest, okay, but that is sufficient for them to perform their analysis. Okay, it's not latest. At the same time, um, if you see here, hardly I mean, logically, you will not perform any write operation, right? Because writing means you're manipulating, right? You don't want, writing or changing anything is like you're manipulating. So you should not, like, you want exactly what happened. Yes, you might make some changes based on, let's say, you have, and we discussed that in the data cleaning. Remember, we made some changes, right? We removed missing elements, we added. So those kind of changes you will make, okay, which is very less. Mostly you'll be performing read. You want to read what happened. Okay, so that kind of database is called OLAP. So we have to do both for our learning. First, we'll focus on OLTP. Going forward, for first session, we'll focus on, like, not first session, like no, we'll first focus on OLTP. Okay, how tables are created, how tables are designed, things like that. So you have OLTP, which is online transaction processing, and so okay, so this is the types of data based on the usage, the way we use. Okay, now straight away we get into data, what do you call, the design, database design. Okay, so before you start coding, before you start this thing, we have to learn how to design, or we need to understand what kind of data is what, or what kind of no, what is the business problem, what is the problem that you're trying to solve, right? Based on problem, you will come up with a list of tables, right? So we call this ER diagram. Okay, entity relationship diagrams. Okay, so what I'll do is, give me a second, I'll just pull up one problem to discuss. Okay, so this is how we, this is data ER diagram is like a flow chart. Okay, so first we design it on paper. Okay, based on the requirement, and we'll do one example now. So the first thing that we do is to identify the entity. Okay, so entity are like your classes that we have in Python, or like actors. We call them actors also in business analyst language. Okay, they are the main. Uh, they are the main. Uh, uh, the No, no, no. So they are the main main player. They are the main player. Okay. So they are the main player. So if I tell you I want to create a library database, for example. Okay. So who are the main players to use library database? Students, faculty, right? So you can call them as members together. You can call them as members, right? So right. So yes. So members to use. Then on the back end you have books, because books needs to be added. You can call it assets, let's say. So assets can be your books, journals, right? So you have assets, you have members to use it, right? So these are your entities who are main and who constitutes the business problem, which constitutes the business problem, right? So library, probably your books and members. These are the two important entities which play an important role. So they will be represented as entity. they'll have their features, attributes we call them, right? So if you take members, so what are the attributes of members? Each member will have ID. They might have type, student, faculty, or whatever, right? They can have type, right? Phone number, email ID, department, all those things, right? Address. So those are attributes of a entity. Okay. Then you have multi-valued attributes. Okay. Multi-valued attributes are attributes which have multi-valued. Okay. So example could be, let's say for faculty, number of or the classes they handle, right? So class they handle will be multiple values, right? It'll have like third semester, fifth semester, seventh semester. So for student courses could be multi-valued. Courses could be multi-valued. So we call them as multi-valued. So thing which have more than one value in one go. So earlier you had phone numbers, right? So phone numbers can have your country code, city code, your number, right? So so they have multi-valued, we call them as. So they'll have more than one value. So when you have multi-values, we put it like double ellipse. Okay. Then relationship. So we talk about the relationship between two entities. Okay. What is the relationship between two entities? Now, for example, um, say books and members only. Okay. So this is important from RD. This is what makes it RDBMS, right? So what makes or what is the relationship between these two? Tell me. What is the relationship between members and books in the library system? What is the relationship? No? No, what is the relationship? So members will issue books. Members can get books. That's the relationship, right? Members can get books. So that's how through I told you, right? Every tables, see, entities will get converted into tables. Every entity will get converted into tables. So when I say two tables are related, okay, so this is the connection between them. Two tables are related. Okay, so relationship. So so now the relationship can be of three types. Okay, relationship can be of three types. So let me go to PowerPoint and talk about it. So we discussed about, see, ER. These are two important. What is ER? Entity and relationship. So every entity will have a relationship, right, with other entity. And the relationship can be one-to-one, can be one-to-one, one-to-many, or many-to-one means the same, and many-to-many. Okay, so let's say your employee and their, say, employee ID, or so employee ID becomes primary key, right? So let's say their office email ID. So if you talk about and stop in Melissa wherever you have confusion, right? So when you talk about employee and their office official email ID, each employee will have unique only one official ID, right? And one official ID will belong to only one person. So okay, so if you have two entities, okay, which one talks about employee, let's say employee name, uh, name, phone number, etc., and other talks about employee email ID, employee workstation, right? So these two tables, okay. So let me try to put it here this way. So let's say you have one table. Okay, so we'll just put table, we'll not put column, or we'll put column also, right? So let's say you have table like this. Okay. So here you have, say, employee data, right? So now employee data will have employee ID, name, let's say address. Okay. You have another table. You have another table which is employee office data, something like this, let's say, right? And here you have employee ID, you have workstation ID, and you have, let's say, email ID. Okay. So now you see each employee, okay, will have only one row here and one row here, right? So if employee ID is 1 and here also employee ID is 1, so one employee ID will have only one name, one address, one workstation number, and one email ID. You can't have two workstation ID. You can't have three email IDs. So this is, we call it as one-to-one relationship. Okay, this is an example of, so you say that employee data and employee office data, they have one-to-one relationship. So generally, when you have one-to-one relationship, we put them in one single table. When you have one-to-one relationship, we put them in one single table. Now you have one-to-many. So let's take employee ID itself. Okay. And let's say you have now, okay, so let me delete it, try to repeat it again. Say department. Department will have department ID, department location, let's say, and department head, let's say. Now, if you look at employee, right, one employee, okay, let me draw first. Okay, so here you have one employee to only one. Now, in second case, okay, you will have many employees belonging to same department,
Yeah.
right? So you will have many employees belong to same department. So we call this as one to many. Now, if you look from department to employee, one department will have many employees, but one employee will have only one department, right? So that's why we are saying that multiple employee will go to department, but two employee, only one employee will have. So one employee can belong to only one department. You cannot work for three departments, right? So you can work on, you can belong to only one department, right? But department obviously will have many, okay, hundreds and thousands of employees, correct? So in this case, we call it as one to many or many to one, depending upon how you look at employee to department, department to employee. That's why I said one to many to one is same. What it says is, in this case, when you have this kind of relationship, we create two different tables. Okay, one table you create employee data, and one table you create department. Okay, so let me add here itself. So recommendation, put them in one single table. No need to put them in different table. You can put them in one single table. Here, recommendation is put them in two tables and create a foreign key relationship. So here what it says is add department ID. Okay, so here employee table will have DID linked to DID of department. So if employee ID 1 belongs to department 1, so you'll have DID 1. Employee 2 also have DID 1, so you'll have employee 2 DID 1. 3, 1, 4, 1, 5, 1, 6, 1, 7. So this DID here is linked to this DID here. So DID in employee is called foreign key. Okay, DID in employee is called foreign key because that is supposed to link you to the different table. Okay, this is what is called relationship. Okay, so it is linking you to the another table. Okay, so this is your foreign key. The third type is called many to many. Okay, so let me have one more. Okay, let's say you have project. Now when you have projects here, so project will have project ID. Okay, project budget, let's say, and you have project head, let's say. Correct? Now if you talk about project head to employee, if you take only project head to employee, okay, one employee will have project head, right? And if let's say that one person can only head one project, then it is one-to-one relationship. But when you have multiple projects, okay, one employee can be part of multiple projects. Yes, you can be part of multiple
Yes.
projects, and obviously
Mm.
projects will have many employees.
Yeah.
So here you are ending up getting what is called as many to many relationship. Okay, you are getting. Now let me change the color. How do I change the color? Text box, design, view, colors. Okay, doesn't matter. Let me try. So, okay, and here I'll make it red color. Or maybe something different. Red. Red is better, right? Okay. So then we'll add more to it, right? Many. So you'll have okay. Right? So you have many to many. So this is the example of okay, example employee and projects. Okay, And so what it says is, now since you have project and employee and many-to-many relationship, it is difficult to represent them in this format. So what we end up doing is we will have to create a third table, okay, to manage the relationship. So here relationship cannot be managed between those two. So we have to create a third table. Right. Okay. So this becomes um okay. So here relationship is also converted into a table. One to one, you don't have relationship. You join them. There is a relationship, so you point them together. So there is nothing called relationship. In one to many, okay, you have relationship. In many to many, because the relationship is complex, we create third table to manage the relationship. Okay. So now what I'll do, I'll take same example and give you, I'll give you an example. So we discussed about employee, department, and table, right? So let's say we create, we'll have some sample data also. Okay. I don't know how many rows, so let me create multiple. Then we'll come and fix it. Oops. So what did we discuss? We discussed employee table, right? Employee, and we say that employee ID will be there. Then we said name will be there. We said address will be there. Then we added other two. What was the other two? Workstation number and email, right? So this is how, no, so here we don't have the phone number, right? Okay, so what we did, we joined employee data and employee office data, and we created employee. So generally, table name should have plural forms, employees. Okay, so what happened, we are able to manage this EID, name, address, workstation number, email ID. We combine them as one table. So employee ID, let's say 1 2 3 4, and I can give name like Sachin, Rohit, okay, Manpreet, okay, Smriti. Okay. Address, let's say Mumbai, Mumbai, Delhi, Hyderabad, let's say. Okay. So we have workstation number. Okay, workstation number 1 2 3 4. Email ID. Huh? So what? That is workstation number, that is employee ID. Nothing will happen. The different column, no. So what? How can data be seen if the column is different here? Hmm? See, you go to a restaurant, they'll have number one is puri, two, vada, three. Is it same as your employee number? Your roll number is also 1 2 3 4, and in canteen also they'll put one idli, one vada. So is that same? No, right? Column is different. Context is different. Column is different. Okay, so this one is different. This is your canteen one. This is your roll number one. So it, same, but the context is different. They are not same. Okay, so a dot com, say B C D. Okay, great. So you have employees here, correct? Next is we spoke about which one? Department. So department. So you have DID, DName, right? D department, DID, DName. Then what did we say? We said D head or whatever. Okay, D code. Okay, department code you will have, right? For okay, so department 1, 2, 3. We don't need more than that. Let me delete it. Okay. So DID, so D name, let's say sales, R&D, marketing, right? Department head is Kapil, Sunil, say Ravi. Department code is, let's say, S1, okay, R1, M3. Okay, so what did we say here? We said that to link these two, we need to create one extra column here called DID, and based on the employee. So Sachin works for sales, I'll put 1. Rohit also works for R&D, 2. Manpreet works for sales, 1. Smriti works for sales, 1. So now you know this table is created. Okay, this is called your foreign key. Okay, this is your foreign key. Yes, so this is how you are able to link this. Next one was projects, isn't it? So you have project ID, PID, you have project title, okay, you have project head or whatever, let's say, budget, let's say. Okay. Okay. So now I'm not able to delete it, looks like. Okay. That's okay. Let me make it closer to each other. Okay. So you have D name, D head, D code. Okay. Now here we said PID title budget, right? So again, I have to do something here also. Okay. So here you have project ID 1, 2, 3, 4, doing ABCD, doing XYZ, doing GHIJ, KBC. Okay. Budget dollars, let's say $1,000,000, 5, 1, 2, 1.5. Okay. So what we said, employees and projects, multiple employees can work for a project, and multiple projects will belong to employee. So now you see, right? So first you understood one to many, right? Using DID, I can link. I know which employee works for which department, right? So we don't have to know for department, right? For employee, we know it is enough. Now here, what we do have to do is we have to create one new table. That's what we said. So we'll create one new table. We call it as employee projects. Employees projects. Okay, and we'll say EPID, employee project. So this is common for this. Now what we do here, we will say here employee ID, and we'll say here project ID. Employee ID 1, 1 or 1, 2, okay. Project ID 3, 4, okay, we'll make it 3, 4, 4. Now you can link employee in projects also, right? Which are the projects Sachin is working on? Which project Sachin is working on? Sachin is working on XYZ and KBC, two projects.
XYZ. Yeah.
XYZ and KBC also.
ABC. Okay.
Yes, sir. No, PID 3 and PID 4, ABCD. XYZ and ABC, not KBC. See, employee ID 1, right? Employee ID 1 is Sachin.
Hmm.
So, employee ID 1, PID 3 and PID 4. So, you have XYZ and ABCD. Sachin is working on
Yeah.
2 projects. Okay. What is department of Manpreet?
Sales.
Sales, yes. Okay. How many employees are working on project ABCD? How many employees are working on ABCD project? Who are those? Yes, so there are two people working on project ID 4, which is ABCD, Sachin and Rohit. Sachin and Rohit is working on ABCD, right? So now you see, you have been able to link all the tables. You have been able to get data for all the tables. This is called as, okay, this is called as your design, okay? Now, but
Mhm.
before this, okay, we create ER diagram. So this is what we get out of ER diagram. Okay, but before that we have to create ER diagram. Okay, so how do you create ER diagram is, so we have how many entities here? How many entities? How many entities? How many entities we have? Mona Lisa?
Three.
Tell 3. So we have 3
Yeah.
entities, yes. So how do we draw entities? Rectangle, right? So we have 3 rect, okay, I'm putting it here. So you have employees, you have departments. Okay, so I'll put it little here so that I can use this space to add attributes
Projects.
and projects. Yes. Okay. Now, employees and departments are related. Yes, they are related. So you will have one rhombus. Where is rhombus? It should be here somewhere. Yes. Okay. Relation. So employees works for, something like that. Works for. Okay. Then you'll have here also. No, here. Between employees and, okay, works on. We'll say works on, something like that. Works on. Okay. Now you can draw, okay, from here to here. Okay. Absolutely no problem. You can draw something like this. Fine. Now employees will also have it from here to here, and then from here to here. Okay. Now we have to draw attributes. Attributes are rhombus. Where is rhombus? Not rhombus. What do you call this one? Okay. So how many attributes did we create here? 1, 2, 3, 4, 5. 5, 4, 3. 5, 4. No, this is projects. Yeah, 5, 4, 3. So 5, 4, and 3. Okay. So you will have 5. Okay. So departments done. Now you need to have for this also. How many? 3. This also has. Okay. This relationship doesn't have, but many to many will have. So if you see a relationship with attributes, it means it has many to many relationship which they are trying to break. Okay. So now you have this. Now you can just name this. So this is how we create a diagram. So this will be your EID. This will be your name, whatever, right? You can fill it. You can fill it, right? I don't have to
Yeah.
do it. Yes.
Yes.
Okay. So save as. I'll save it on desktop for now, and I'll upload it on the same location. I'll share the location once again. Okay. So so we'll stop here. Tomorrow we'll see how to create database. Okay, we'll create database with these things. So we'll create
Yeah.
table, we'll create columns, and we'll link them together, and we'll see how to add table, rows and columns, and we'll see how to add values, how to edit all those things. We'll see tomorrow. Any questions so far?
No.
Awesome.